सबसे पहले तो आप सभी बच्चों को और आपके परिवार को लोहड़ी और मकर संक्रांति की बहुत बहुत शुभकामनाएं। तो प्यारे बच्चों, हम आज स्ट्रेट लाइंस चैप्टर के कुछ और टर्म्स जो है वो डिस्कस करने जा रहे हैं। तो फर्स्ट ऑफ ऑल लेट अस डिस्कस द इंक्लिनेशन ऑफ ए स्ट्रेट लाइन। इंक्लिनेशन ऑफ ए straight line. Inclination of the straight line is the angle subtended by the straight line with the positive direction of x-axis. This is the inclination of this straight line N. If theta is the inclination of the straight line, then the slope of the straight line is m is equal to tangent theta. The slope of any straight line is represented by the letter small m of the English alphabet. The slope of the straight line m is equal to tangent theta. This is the formula for the slope of a straight line. Now let us discuss the second formula of the slope of the straight line. That is 2-point form. If 2 points are given on the straight lines and inclination is not given, then what is the method to find the slope of the straight line? We are discussing this formula. If P and Q are the 2 points whose coordinates are x1, y1 and x2, y2, then this is P and this is Q, and if we draw perpendicular PM and PM on x-axis, then this distance OM is x1. If it is x1, y1 and it is x2, y2, then it becomes OM is x1 and ON is x2. MN is x2 minus x1. And if we draw perpendicular PR on QN, then this PR becomes x2 minus x1 and this QR becomes y2 minus y1. Hence, if this inclination theta is not given to you, then you can find the value of tan theta, which is slope, directly by the formula of perpendicular upon base. So therefore, m will be is equal to tan theta will be is equal to perpendicular is y2 minus y1 and base is x2 minus x1. So this becomes the second formula for the slope of a straight line. Slope of the straight line is m is equal to tan theta if inclination is given to you, and slope of the straight line is y2 minus y1 upon x2 minus x1 if inclination is not given to you, what 2 points on that straight line are given to you. So these are the 2 formulas for the slope of a straight line. That's all. Now let us discuss 2 properties of the slopes. If 2 straight lines are parallel to each other, then their inclination will be same. Like these are the 2 straight lines. They are parallel to each other. Hence their inclination is same. This is equal to this. If inclinations are same, then their slope must be same. If L1 is the first straight line and L2 is the second straight line and they are parallel, then theta 1 and theta 2 will also same. This is theta 1 and this is theta 2. This is the inclination of the first straight line and this is the inclination of the first straight line and this is the inclination of the second straight line. They are parallel, then angles subtended by them with the x-axis will be same. If inclination are same, then their slope must be same. So hence first condition is, if two straight lines are parallel to each other, then their slopes must be equal. Condition of parallelism. If two straight lines are parallel, then their slope will be equal. If either m1 will be equal to m2, if L1 is parallel to L2. If two lines are parallel to each other, then their slope must be equal. If slopes are equals, then line must be parallel. Inclination will be same. So this is the first condition of the parallelism, condition of parallelism कहते हैं इसको. And second is the condition of perpendicularity. If two lines are perpendicular to each other, then the condition is the product of their slope is equal to -1. This is the condition. So let us discuss that second condition of perpendicularity of the two straight lines. Now let us discuss the second property of the slope of a straight line. The condition of perpendicularity. If two straight lines are perpendicular to each other, then the product of their slope is equal to -1. This is also called condition of perpendicularity. So let us discuss with the diagram. Let L1 is the first straight line whose inclination is theta 1 and L2 is the second straight line whose inclination is theta 2 and they are perpendicular to each other, making angle 90 degree with each other. This angle is 90 degree. This is theta 1. This is theta 2, inclination of the second straight line. Then what is the condition between these? This is the exterior angle of this triangle. And exterior angle is equal to the sum of the interior angles. These two interior angles. Opposite interior angles. So theta 2 must be equal to theta 1 plus 90 degree. बाया कोण अंदर के सुमुख कोणों के योग के बराबर होता है किसी ट्राइंगल में. So theta 2 is equal to 90 degree plus theta 1. Now m1 is equal to tangent theta 1 because theta 1 is the inclination of the first straight line and m2 is equal to tangent theta 2 because theta 2 is the inclination of the second straight line. And substituting the value of theta 2 as 90 plus theta 1, we get, because theta 2 is equal to 90 plus theta 1. And 90 plus theta 1 is the second quadrant. And in the second quadrant, tan is negative. And due to this 90 degree, this tan becomes cot. Minus cot theta 1. T ratio of 90 plus theta. Now this becomes m2 is equal to minus cot theta. Now we have to prove this property. Multiplying m1 and m2 is equal to tan theta 1 multiplied by minus cot theta 1. That is equal to tan theta 1 multiplied by minus 1 upon tan theta 1. Cutting, we get minus 1. Hence m1 m2 is equal to minus 1. This is the condition of perpendicularity of the two straight lines in terms of their slopes. That's all. Now let us discuss the exercise 10.1, question number 6, the application of the slope of a straight line. The question is, without using Pythagoras theorem, show that point A 4, 4, point B 3, 5 and point C minus 1, minus 1 are the vertices of a right angle triangle. So what is the procedure of this type of questions? We have to find the slope of AB by 2.4 by 2 minus y1 upon x2 minus x1. That will be the m1. Slope of BC again 2.4 y2 minus y1 upon x2 minus x1. And then slope of AC, that will be the m3 y2 minus y1 upon x2 minus x1. Then any one of the pairs, either m1 m2 will be minus 1 or m1 m3 will be minus 1 or m2 into m3 will be is equal to minus 1. If any one of the pair of these slopes is equal to minus 1, then we can say that one of the angle of this triangle is 90 degree. Hence, these are the vertices of a right angle triangle. This is the procedure to solve such type of questions. So, let us find the solution of this question. According to the question, the given vertices of a triangle are A 4, 4, B 3, 5 and C minus 1, minus 1. Now, first of all, slope of side AB is equal to m1 is equal to y2 minus y1 upon x2 minus x1. This is the formula of the slope. That is equal to 5 minus 4 upon 3 minus 4. That is 1 upon minus 1. That is equal to minus 1. Value of m1 is equal to minus 1. Now, slope of the side BC. Slope of the side BC is equal to m2 is equal to, again applying this formula in B and C, we get minus 1 minus 5 upon minus 1 minus 3 minus 6 upon minus 4, that is minus minus cancel 3 by 2. This is the value of m2. Now at last, slope of the side AC. Again applying this formula for the slope. we can find the value of M3. Now slope of the side AC is equal to -1 minus 4 upon -1 minus 4. Applying the formula of y2 minus y1 upon x2 minus x1 for the slope. We get -5 upon -5. After cutting, we get 1. Now it is clear that M1 into M3, that is -1 into 1, that is equal to -1. The product of the one of the pair of these slopes is equal to -1, and the product of the other pairs is not equal to -1. Therefore, we can say that one of the angle of this triangle is 90 degree. So therefore, the given vertices are the vertices of a right angle triangle. Hence the result. यही हमारा रिक्वायरमेंट थी कि so that these are the vertices of A, B and C are the vertices of a right angle triangle without using the Pythagoras theorem. We have not used here any Pythagoras theorem or distance formula. We have used the method of slopes and the perpendicularity conditions. So this is the procedure. One of the pair of the slopes of the side product is equal to -1. Hence, these are the vertices of a right angle triangle. That's all.